Torej, rekli smo, da si bomo pogledali nekaj čisto recimo pač kratka, to je enega od Stanfordovih tečajev.
The design and analysis of algorithms is the interplay between, on the one hand, general principles, and on the other hand, instantiations of those principles to
razlaga tukaj najbolj na začetku, zakaj je dobro algoritme poznati.
And have the potential is distributed shortest path routing. So what I want to talk about first is distributed shortest path routing and why it's fundamental to how the internet works. So let me begin with a kind of very non-mathematical claim. I claim that we can usefully think of the internet as a graph, as a collection of vertices and a collection of edges. So this is clearly an ambiguous statement. There's many things I might mean, as we'll discuss, but here's the primary interpretation I want you to have for this particular video. So to specify this, the vertices I intend to be the end hosts and the routers of the internet. So machines that generate traffic, machines that consume traffic, and machines that help traffic get from one place to another. So the edges are going to be directed, and they're meant to represent physical or wireless connections, indicating that one machine can talk directly to another one, by the physical link between the two or direct. So it's common that you'll have edges in both directions, so that if machine A can talk to machine B directly, then also machine B can talk directly to machine A, but you definitely want to allow the possibility of asymmetric communication. So, for example, imagine I send an email from my Stanford account to one of my old mentors at Cornell, where I did my graduate studies. So this piece of data, this email, has to somehow migrate from my machine local at Stanford to my mentor's machine over at Cornell. So how does that actually happen? Well, initially there's a phase of sort of local transportation. So this piece of data has to get from my local machine to a place within the Stanford network that can talk to the rest of the world. Just like if I was trying to travel to Cornell, I would have to first use local transportation to get to San Francisco Airport, and only from there could I take an airplane. So this machine from which data can escape from the Stanford network to the outside world is called the gateway router. The Stanford gateway router passes it on to a network whose job is to cross the country. So last I checked, the commercial internet service provider of Stanford was Cogent, so they of course have their own gateway router, which can talk to the Stanford one and vice versa. And of course, these two nodes and the edges between them are just this tiny, tiny, tiny piece embedded in this massive graph comprising all the end hosts and routers of the internet. So that's the main version of a graph that we're going to talk about in this video. But let me just pause to mention a couple of other graphs that are related to the internet and quite interesting in their own right. So one graph that has generated an enormous amount of interest and study is the graph induced by the web. So here, the vertices are going to represent web pages, and the edges, which are certainly directed, represent hyperlinks, that one web page points to another one. So for example, my home page is one node in this massive, massive graph. And as you might expect, there is a link from my home page to the course page for this class. It is, of course, essential to use directed edges to faithfully model the web. There is, for example, no directed edge from this course's homepage to my own homepage at Stanford. So the web really exploded around mid-90s, late 90s, so for the past 15 plus years there's been lots of research about the web graph. I'm sure you won't be surprised to hear that around the middle of the last decade, people got extremely excited about properties of social networks. Those, of course, can also be fruitfully thought of as graphs. Here, the vertices are going to be people, and the links are going to denote relationships. So, for example, friend relationships in Facebook, or the following relationship on Twitter. So notice that different social networks may correspond to undirected or directed graphs. Facebook, for example, corresponding to an undirected graph, Twitter corresponding to a directed graph. So let's now return to the first interpretation I wanted to focus on, that where the vertices are end hosts and routers, and edges represent direct physical or wireless connections, indicating that two machines can talk directly to each other. So going back to that graph, let's go back to the story where I'm sending an email to somebody at Cornell, and this data has to somehow travel from my local machine to some local machine at Cornell. So in particular, this piece of data has to get from the Stanford gateway router, in effect the airport for Stanford's network, to the Cornell gateway router, so the landing airport over on Cornell's side. Now, it's not easy to figure out exactly what the structure of the routes between Stanford and Cornell look like, but one thing I can promise you is that there is not a direct physical link between the Stanford gateway router and the Cornell gateway router. Any route between the two is going to comprise multiple hops. It will have intermediate stops. And there's not going to be a unique such route. So if you have the choice between taking one route, which stops in Houston and then Atlanta and then in Washington, D.C., how would you compare that to one which stops in Salt Lake City and Chicago? Well, hopefully your first instinct and a perfectly good idea is, all else being equal, prefer the path that is in some sense the shortest. Now, in this context, shortest could mean many things, and it's interesting to think about different definitions, but for simplicity, let's just focus on the fewest number of hops, equivalently the fewest number of intermediate stops. Well, if we want to actually execute this idea, we clearly need an algorithm that, given a source and a destination, computes the shortest path between the two. So hopefully you feel well equipped to discuss this problem, because one of the highlights of part one of this class was the discussion of Dijkstra's shortest path algorithm and a blazingly fast implementation using heaps that runs in almost linear time. We did mention one caveat when we discussed Dijkstra's algorithm, namely that it requires all edge links to be non-negative, but in the context of internet routing, almost any edge metric you'd imagine using will satisfy this non-negativity assumption. There is, however, a serious issue with trying to apply Dijkstra's shortest path algorithm off the shelf to solve this distributed internet routing problem. And the issue is caused by the just massive distributed scale of the modern day internet. Probably back in the 1960s, when you had the 12-node ARPANET, you could get away with running Dijkstra's shortest path algorithm, but not in the 21st century. It's not feasible for the Stanford gateway router to maintain locally a reasonably accurate model of the entire internet graph. So how can we elude?
No, to je bilo delno tudi odgovor. Tvoje vprašanje, zakaj enostavno ne moramo vzeti neke črne škatle, Dijkstrav algoritem, pa ga direktno recimo pač uporabljati. Tako da, no, dejstvo je, da pri upravljanju interneta, upravljanju prometa pri recimo pač internetu dejansko zelo pogosto nastopa ta problem, problem najkrajših recimo pač poti, in dejansko je v enem od protokolov, saj, veste kaj je protokol? No. Protokol je pač, kako se mora človek obnašati, ne? To se pravi, diplomatski recimo pač protokol, ali pa kako, mislim, stvar pač tema, verjetno ste že slišali za številne recimo pač zgodbice okrog tega, kako se nekdo, ki naj bi se znal držati nekega diplomatskega protokola, ni držal tega protokola in potem so bile recimo pač težave. Ampak, a ste že kdaj recimo pač pomislili, ne, zakaj sploh obstaja pravila obnašanja med diplomatov? So res neki to posebnega, da mora biti posebno recimo pač pravila. To je znano zato, da so to fancy. Zakaj? Kaj mislite, zakaj? Zakaj so se recimo pač spomnili protokole? To se pravi, pravila obnašanja pri komuniciranju med dvema diplomatoma, eno skupino diplomatov pa recimo prišli. Zakaj imajo tam pravila? Zakaj? Kaj mislite, zakaj? Zakaj so se jih spomnili? Zakaj so jih recimo pač uvedli? Zakaj so rekli, da bi bilo dobro določiti? Imate kakršnokoli recimo pač idejo? Zakaj? Varnosti, kaj misliš s tem?
Zmeri tako bom pomoče tega odstranjanja hitre.
Ja, ne, mislim, stvar je pač, mislim, v osnovi, ne, je recimo pač protokol, recimo pač ta. Aha, jaz sem delegacija iz države X, tam je delegacija iz države recimo pač Y, ne, zdaj pa gremo tamle, mislim, tisti recimo pač mizem, pa se bomo zdaj recimo pač pogovarjali. In večina zadev, od tega, kako se bomo recimo pač usedli, do tega, kako se bomo recimo pač pozdravili in tako naprej, je določena z protokolom. Zakaj? Ja, dejansko je razlog, recimo pač tem, protokole, so zgodovinsko, če pogledate, kar se tiče diplomatov, so enostavno morali recimo pač uvesti, ko je prišlo do stika različnih kultur. Stvar je pač v tem, recimo, eno banano, se ni stvar diplomatskega protokola, da ne bo nesporazum, ampak recimo, mi načeloma pokimamo za pritrdilno zadevo. V nekih drugih, recimo pač kulturi, vem, da v določenih delih, recimo pač Azije, to dejansko pomeni zanikanje. Recimo pač določeni, recimo pač kulturi, bi bilo strahotno, recimo pač nevljudno, če bi se človeka dotaknil. Stvar je pač o tem, načeloma, vsaj kolikor so mi recimo pač razlagali, boš nekega Japonca zelo recimo pač užalil, če se boš poskušal z njim rokovati. Je to dejansko žalitev. In tako naprej. In zaradi tega, ker je pač prihajalo do recimo pač stika različnih recimo pač pravil, so uvedli protokol. Kaj je to zvezi z internetom? Zakaj pa mislite, da so pri internetu protokoli?
Naprimer, imamo mrežno kartico, od 6 različnih proizvajalcev, zdaj, če bo vsaka delala, naprimer, ena bo delala na RS-2321, TTL, ojej, bo registruta.
Stvar je pač o tem, ja, zaradi tega, ker del recimo pač interneta so zelo različne naprave. In hardversko, in softversko. Različna programska recimo pač oprema, različni operacijski recimo pač sistemi. In vsak ima nek svoj skupek recimo pač pravil, kako naj bi bila določena zadeva narejena. In zaradi tega so se pač spomnili skupne recimo pač protokole, to se pravi skupen spisek recimo pač pravil, kako se mora določena recimo pač zadeva obnašati, da se bo lahko sporazumevala z recimo pač neko recimo pač drugo. No, in med drugim, teh protokolov je malo recimo pač mori. En od recimo pač protokolov, ki ga ves čas uporabljate, je recimo HTTP, Hypertext Transfer Protocol. To ne smete zamešati z HTML-jem. HTML je Hypertext Markup Language. Je pač govorijo o jeziku, kako mora biti oblikovane spletne recimo pač strani, da se potem ustrezno tolmačijo v brskalniku. HTTP je pa protokol, to se pravi spisek recimo pač pravil, ki pove, kaj morajo določeni računalniki razumeti, da se lahko med sabo recimo pač sporazumejo. To se pravi, na kakšne ukaze lahko pričakuje, pa kako se mora na, recimo pač ukaze odzvati. Ena od zadev, na katero ste, če mičkrat nazaj pomislite v tiste vaše prve stike z recimo pač internetom, ste verjetno naleteli na 404 številko. Da je nekaj narobe. Stvar je pač tema. To je pač dogovorjena oznaka, s pomočjo katere si računalniki, ki sodelujo pri izmenjavi podatkov, v sklopu z tem svetovnim recimo spletom, povejo, da je bilo nekaj recimo pač narobe pri zahtevi za določeno spletno stran. Mi smo zahtevali neko recimo pač spletno stran, ta strežnik pa tiste spletne strani ni mogel dati. Iz različnih vzrokov. Najbolj pogosto zaradi napake 404, to se pravi zaradi tega, ker tista stran ni obstajala. V tiste strežniku tiste strani recimo pač ni bilo. In zaradi tega je bil pač dogovor, da v tem primeru se tisti računalnik odzove z pomočjo kode 404. To je del HTTP protokola. No, in eden od teh protokolov je tudi Open Shortest Path Finder, to se pravi eden od teh recimo pač protokolov, ki pove, na kakšen način naj se računalniki oziroma omrežne naprave, ki jim rečemo usmerjevalniki oziroma routerji, na kakšen recimo pač način naj se izmenjajo podatke da bodo povedali, da bodo recimo pač vedeli, kako na najhitrejši način posredovati določeno zahtevo z enega računalnika do tistega recimo pa ciljnega računalnika. No, obstajajo tudi drugi recimo pač protokoli, ki povezujejo dele tega recimo pač mreža, recimo pač Border Gateway protokol, ki tudi uporabljajo te recimo pač najkrajše poti. Če vas zadeva bolj recimo pač zanima, pogledajte te recimo pač linke kot ta. Ne? No, vsi ti kot taki pa obstajajo, mislim, so del skupine tako imenovanih razdaljo vektorskih usmerjevalnih protokolov. Ne? Ok.